Hello everyone, and welcome to another Zozin session. Let's do this 17th day of Advent of Code in the Gods Temple. Trick shot. You finally decode the elf's message. Hi, the message says. You continue searching for these sleigh keys. Ahead of you is what appears to be a large ocean trench. Oceanic trench. Okay, I see. Could the keys have fallen into it? You'd better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the x, forward, and y upward or downward if negative direction. For example, an initial xy velocity like 0,10 would fire the probe straight up, while an initial velocity like 10 minus 1 would fire the probe downwards at a slight downward angle. The probe's xy position starts at 0, 0, then it will follow some trajectory by moving in steps. On each steps, these changes occur in the following order. The probe's x position increased by x velocity, the probe's y position is increased by y velocity. Due to the drag, the probe's x velocity changes by 1 towards the value 0. That is, the decreases by 1 if it is greater than 0, increases by 1 if it's less than 0, or does not change if it's already 0. Okay, so we'll figure out what that means a little bit later when we're gonna start implementing this. Due to the gravity, the probe's y velocity decreases by 1. Okay, so this is something that I implement every time I make a simple platformer game, right, with the basics, physics, and stuff like that. Should be pretty straightforward. So, though I usually do that in floats, so here everything seems to be in integers, which is a little bit easier, right, because there's no floating point shenanigans going on, which is nice. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within the target area after any step. The submarine computer has already calculated this target area, your puzzle input. For example, target area x 2030 and this one. This target area means that you need to find initial xy velocity value such that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is at least minus blah blah blah. Given this trajectory area, one initial velocity that causes the probe to be within the target area is 7 to 20, almost at 20. In this diagram, S is the probe's initial position, 0 is the x coordinate, increases to the right, blah blah blah. Okay, so another initial velocity, blah blah blah, another blah blah blah. The initial trajectory that doesn't cause the probe to be within the target area after any step is 70. Okay, so it can tunnel. So it is allowed to tunnel through the area. That's very interesting. So it literally teleports. Cool. Thank you. Thank you that you don't force us to actually like take the tunneling into account, which is nice. The probe appears to pass through the target area, but it never within it after any step. Instead, it continues down to the right. Only the first few steps are shown. If you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? The above example, using an initial velocity of 69, is the best you can do, causing the probe to reach the maximum y position of 45. Any higher initial y velocity causes the probe to overshoot the target area entirely. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after any step. What is the highest y position it reaches on this trajectory? Okay, so, and that leaves the question, what's going to be the part 2? Is the part 2 gonna force us to take into account the tunneling? Because I hate dealing with tunneling, so I don't even know. Oh, you have to parse this shit. Thank you so much. Though I'm not even sure if I want to parse this entire thing. All right, so I can just like encode it straight into my code. So maybe no parsing is required for this particular situation, right? So all right, let me go ahead and create a new day. So new day is going to be 17. All right. I have to provide the AoC first. Just a second. I probably need to sneeze. Debated. Excuse me. So let's continue. All right, so I'm gonna actually quit this one and quit this one and run AoC virtual machine. All right. Should have actually added the samples so I can copy paste them within the temple OS. All right. I think that was very dumb of me. Okay, let's go back. So I'm gonna mount the AoC 2021 one more time. Right, and I'm gonna go there with Emacs, so it's a little bit easier for me to navigate and do things. All right, so sample txt. Okay, so this is gonna be our sample. All right, and I'm gonna like put a new line just in case, and input txt like this. So the actual puzzle input is going to be this thing. I don't think it makes any sense to even try to parse that. We can just like put that into the code, and that's why I need to have it here. So it's easier for me to copy paste within the temple OS. Okay. All right, 17, and here is my sample, which I'm going to copy paste and put it in here. Right, so here is the sample. I'm gonna put it in a comment for now, at least. So let me see, target area X and Y. So I'm wondering, do we want to have like some sort of a structure for points? Maybe not for now, we'll see. So I'm gonna just define something like init X is gonna be 20 and init Y is going to be -10. Then init X is going to actually, so maybe I'm gonna call it min, right, min X, and this is gonna be max X is equal 30, and max Y is going to be -5. Okay, that is very cool. That is very cool. So, and what we want to do essentially is to simulate the entire process, right? To simulate the entire process. It would be kind of nice to just have a function, right? Simulate, which actually accepts initial velocity, right? So let's call it Vx and Vy, and maybe also initial position, though initial position is known to be like 0, 0, so it doesn't matter. And that entire thing will actually return a true or false, indicating whether it, you know, hit the area or not, and maybe it will also return the maximum height, right? So let's actually do something like max height. There we go. Return false. So, and essentially we can try to brute force this entire thing, right? We can try different, you know, different initial velocities and stuff like that until we find something that actually fits there. Though we need to define the boundaries of the simulation at some point, right? So it's going to be rather interesting. All right, so I'm going to start with x equals 0 and 64 y equals 0. Right, so, and until some sort of a condition, I don't really know when we're going to stop, right? Though we can at least have something like in target, right? So where we're going to accept x and y, i64y, and in here we're going to just check whether this entire thing is within the target, right? So min x, you know what, I'm gonna actually call it minx, because I don't want to type additional underscore, because it forces me to press shift, and pressing shift like causes all sort of weird behavior within TempleOS, so it's better not to actually touch that. So I suppose this is how we're gonna actually check for that, max x, and min y less than that, max y, maxi, right? So I think this is basically it, right? And while we are not in target, right, while we are not in target, we're going to be just simulating this entire thing. we're gonna just like code the rules that are here, right? So props position increases by x velocity, right? Incrementing by the x velocity, cool. Y is incremented by the y velocity. Due to the drag props, x velocity changes by 1 towards the value 0. Okay, that's very interesting. So that means if it's positive, it needs to be negative, right? If it's negative, it has to be positive. That is, it increases by 1 if it's greater than 0, decreases. Okay, so we can try to do something like this. We can take a sine of x, right? And sine returns -1 or 1, and basically we can negate it, right? Due to the drag, the prob's x velocity changes by 1, so velocity x velocity, so that means it has to be vx, I suppose, right? It has to be vx, and then we're gonna just add it, right? So sine is supposed to return -1 or 1 or 0, depending on the sign of this entire thing. Okay, and due to the gravity, the prop's y velocity decreases by 1. Okay, so that is also understandable. And we're gonna just like decrease it by 1, maybe plus -1, right? Because I want to have plus equals for all of these things. Right, there we go. So, and max height, essentially, it's the maximum y, right? It's the maximum y. And I suppose one of the things we can do in here is, you know, I want to rename this thing, it's too long to type. Generally, the TempleOS text editor is so bad that you want to come up with smallest name possible, so you don't have to type too much. It is very important. So since it's maximum, we want to assign I64 minimum, right? We're assigning the minimum, and here, I don't even know how we're going to do that. I suppose we can just put it somewhere here, right? And it's going to be max h, maximum I64 between max h and the current y, right? So, and in here it will return true essentially. So, but this is like only one condition, right? So this is basically only one condition. The second condition is when we actually overshoot, we need to detect when we completely overshoot the area. Right. When we completely overshoot the area. So let me take a look at the input actually. So cool thing here is that x, the area in x is located to the right, right? It is located to the right. In case of the input, it's also located to the right. So one of the conditions is we can use is essentially the current x is smaller or equal to the maximum x, right? So we're gonna basically assume that we're moving like towards the area, and if at any point x becomes bigger than the maximum x of the area, there's no point in continuing doing this entire thing. So yeah, it's like, yeah, we better stop. So, and the actual result here is going to be in target, right? If in target, that means simulation went successful and we found the thing that actually produces what we want. And then we have a max height. So that's pretty much it. Right, that's pretty much it. So I also want to take a look at the input. All right, I'm going to copy paste it into my file somewhere here. So this is going to be the comment. All right, so let me try to compile this entire thing and see if it compiles. Okay, first try, compiled it first try. So let me now see if we can simulate at least the sample. All right, so I'm gonna do simulate, and the velocity at which it hits the thing. Given this target area, one initial velocity that causes the prop to be within the target area is 7 and 2. Okay, so if we put 7 and 2, so I also have to provide the max h. Right, I64 max h. I probably don't need to initialize it because it's initialized within the process itself. And in here, we can do something like this. If it was successful, we're going to print success. Max height is this one. So it's going to be max h. And in here, we're going to do something like failure. Right, and let's actually see what's going to happen. So success, the max height was 3. Which is rather interesting. Was it actually 3? 1? Yeah, it was actually 3. If this is the 0, 1, 2, 3, it was in fact 3. So I think we simulated that successfully. So we can try 6, 3 now, right? So it's the same area. Okay. So this is going to be 6, 3. Pretty straightforward. 6, 3. And the max height was 6. 1, 2, 3, 1, 2, 3. In fact, it is 6. And for the 9, 9, 0. The height was 0 basically because it actually went like down. Okay. And let's actually take a look at this one that doesn't actually hit anything. 17 minus 4. Right. 17 minus 4, right? And it said failure, and for the failure I forgot to provide a new line, right? So let's actually put it in here, and it is in fact a failure. So that is very, very cool. So we can basically have initial velocity, and we can very quickly check whether it's success or not. So the thing now, we can try to understand how we can brute force this entire process. I hope you can just do brute force. Should be pretty straightforward, right? So let me think. I also kind of want to visualize this entire thing, but I'm not sure if I'll spend like enough time doing so. So let me think. So maybe I want to draw some stuff. Simulating all of this stuff. What I'm thinking is that it probably doesn't make sense to, you know, let me see. So there's some sort of like area of values where it doesn't make sense to even go there, right? So if we have something like this, right? If we have something like this, so this is the 0, right? This is the 0, and now can we somehow identify like a minimum and maximum of x, right? So again, first of all, you cannot do minus x. There's no point in throwing this entire thing in the opposite direction whatsoever, right? So all of the x's are going to be greater than 0, right? So they're going to go up until there. Though there is another limitation in here. So this thing should not be bigger than max x, right? Because if you try to do max x, you basically will overshoot, right? So this is basically the range within which you can do this entire stuff, right? So then, in terms of y, if I just throw up, right, if I just throw, I can even say that the range here is going to be 1, right? Because if you make x equal 0, so you're going to only throw up, and it's going to just bring back to here, right? So yeah, so it's going to be that. And if you're going to have like a negative y, it's going to be just that. In terms of y, y can be 0 though. Y can be 0. That's totally fine. So that means you just throw in here, and then it will go down or not go down or whatever. So yeah. So another interesting condition. So we may wanna also check. We may also want to check that y y is less or equal max y, because for the situation like that, right, for the situation like that, when x is very small but y is high, it will take a lot of time to reach the situation when it goes over this entire thing. So I think it's better to check both of these things. So essentially, it kind of like defines this area, right? If at any point your probe goes into that area, that's it. There is no point in even trying further, right? You know what I'm talking about? So there's no kind of point in even going into that area. So, and what's going to be the maximum y that it makes sense to try? I guess you can also say max y, right? It's the safest bet that you can take, right? So just like iterate through -1 max x and from 0 to max y, and like just try this entire rectangle, right? And though in terms of, yeah, you also want to go up. Yeah, so something wrong with the y. I think something wrong with my y. Though, since we're maximizing the height, it probably makes sense to, yeah, it probably makes sense to not even go into negative for sure. So you can only like throw up, but how up can you throw? How up can you throw? I think you can throw up until you are stop succeeding or something, if that makes any sense. Until you stop succeeding. So, yeah, let me see. Okay. So I64 Vx is going to be equal to, well, we wouldn't need to initialize this entire thing. So with y, I'm not quite sure what's going to be with y. So it's going to be definitely at least 1, otherwise you're not doing anything significant. But for how long do we want to go up? For how long? So what's going to be the maximum in here? Right. What's going to be the maximum? Because if there is some sort of a situation when it, no. So if you pick very small y, it does not actually reach anything. If you then at some point it starts to reach something, and at some point it stops reaching again. So there is like this weird area where you are failing, right? Where you're failing, then you stop failing, and then you fail again. So what I'm thinking is that basically, can we just like rely on that, right? So essentially we're gonna iterate for y, and we're gonna just ignore if it's failing, right? We're gonna just ignore if it's failing, and then it's not failing, and then it's failing again, or something like that. Though it would be better to just like find the best, like the range, find the range for this entire stuff. So though what I'm thinking is, one of the things we can just try to do is, for this specific square, just simulate as big as possible, right? So just as big as possible, maybe like 100, right? And just see within which area it is succeeding and within which area it is failing. I think that will be rather interesting, right? Vx, so it could be probably 0, Vx, and then this one cannot be 0, and this one is definitely, Gonna be less than max x plus vx plus vx. Right, and what I can do in here, can I simulate this entire thing? So simulate vx vy with the max height. And what I probably want to do, like I want to have some sort of a square that will tell me this entire thing. So I want to like just put that into some sort of area in here. So let's call it maybe a map, right? This is going to be a map, and in here we're going to have like 101 of these things, and in terms of that stuff is going to be, so let's actually put 100 plus some sort of a thing, max x plus another sort of a thing. Right, and in here, while I'm simulating everything, I just want to see what's going to be the result of the simulation here. Vx, vy, there we go. And then I just want to print this entire thing, if that makes any sense, right? So I just want to like see that. Though, because of that, it probably doesn't make any sense to like have that as an array, right? I can just straight up render it, right? So I can just straight up render it. So if simulation is successful, right, I'm gonna print hash. Otherwise, I'm gonna be printing the like some sort of a dot, I suppose. That makes sense, right? So, and this is not the space. Not the space, right? It's more of a like space of the velocity, so to speak, right? So I just want to see how it behaves. All right. So, and in here we want to provide like a new line. So maybe I'm gonna actually like 100 in terms of y is probably too much, but should be fine. Okay. So we've got something, right? And in all of these cases, there are not successful, which is rather strange. None of them are successful, so that's really, really weird. Okay, Vx, Vy. So, what? That is so weird. Max X. Because I'm pretty sure within this entire stuff, we should hit 7 and 2. But we never actually hit 7 and 2. That is so wild. Why? So let me, yeah, you should have at least something successful, but it's not there. What am I missing? Right. Did I modify something weirdly? If Vx is equal to 7, and Vy is equal to 2, you have to print something like hey, right? So we are hitting that thing, but this thing is telling me that no, it is not true. Vx, Vy. I just tested it. So if I put 7 and 2 in here, it is never successful. But it was successful, wasn't it? Just a second ago. Was it not? Am I going crazy? Like, it was just successful. Like, is that TempleOS playing tricks on me yet again? Simulate 7 to max H, right? And if it's successful, I want to print... Like, I just did that and it worked and I didn't modify anything. What the hell are you talking, TempleOS? What the hell is going on? Why? Okay, so failure, right, and if I do that, it is failure now. It worked before. What did I modify? What did I modify? I just tested everything. Man, what the fuck? Seriously. Like, I'm so disappointed. What am I missing though? It's in target. Did I... There is a situation when I pass by a pointer and it's not a pointer anymore or something like that. Is that the situation yet again? So... the fuck? This is so soul crushing. Like, it worked before and now it just all of a sudden doesn't work because fuck you. I'm... Okay, I didn't even know. Okay. Let me make a small break because I think I'm going crazy. Like the template is going to be a death of me, seriously. Like it's just something works, something suddenly doesn't work, and the compiler is not helping you at all. Just a second. I just realized that there is something that I did change since the last time. So I think that's this one. Okay, so this is not a good thing as an indicator of end of the loop. Okay, so this is not TempleOS, right? Just a second. Okay, so cool. So now it is not failing, it is always successful for whatever freaking reason, which is really weird. So I wouldn't expect this entire thing to be successful at all, but it is in fact successful. Why? Why is it successful? Like I would expect it to not be successful at some point, but it's just like, yeah, it is always successful now. Even when, well, I mean, I can try to put like Vx to 0, right? Vx to 0. And there should be at least one moment when it's not successful, but it is suddenly successful. That means it hits the target every time. Right, it just does hit the target every time. So I would suppose if I add like 10 to this entire thing, it is still always successful. Okay, so everything is wrong. Everything is completely wrong. Why would it be like that? Why would it be? It just doesn't make any sense. Probably, maybe I want to actually draw the entire thing, but visualizing this entire stuff is actually, it will take too much time. Right. I really don't want to spend time visualizing this entire thing. It's just like coding this thing is going to take like an hour, maybe. Also fighting with TempleOS, so it's better not to even touch that. Okay, so I think I need to make a proper break and refill my cup of tea and maybe like think about this this entire thing while I'm making a cup of tea. I've got an interesting idea. What if that's because of some sort of like weird operator precedence when I'm using this feature of TempleOS? So what if I have to like rub that in parentheses because the parser cannot like properly understand what the fuck I mean in here? So that would be kind of disappointing. Well, it is not the case, at least. All right, so this is not the case for sure. But it was worth the try, right? So it was worth the try. Interestingly, so there are some situations when this is like negative, right? 17 minus 4. Interestingly, maybe that's actually true. Maybe that's actually true. Like, doesn't matter how high you send it, it will always kind of be there, but it doesn't make much sense. Right, what if I increase this x? No. Okay, what if I will put like -5 in here? Will it stop doing anything? So it stops at -4. Right, it stops at -4, so that means somewhere here it should have a dot, but it just doesn't. It simply doesn't, so it says all of these things are successful. Yet again, I probably need to go back to my code. Alright, so I really regret that I keep removing that piece of code because apparently it is very useful. So, alright, simulate. So what was that? 17 minus 4, 17 minus 4. Max h, right, and then I just want to print that entire thing, max h, and otherwise this is the failure, right, failure, there we go. So it is failure, and I would assume that here, right, here, we do hit 17 minus 4 at some point. Cut that out! Cut everything out! Oh my god. Please, edit everything that out. Please, 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 please. Okay, whatever. You didn't see anything. Like pretend that this never happened. Okay, so, and the entire thing actually hangs, which is good. I think it is doing something. Right. Yikes, that's the most yikes moment I've ever had in my entire life. Anyway, so I presume that maybe it hangs on some of the existing values. Right, so let me... Okay, I'm gonna blame the font of TempleOS for that. The font makes it kind of difficult to spot this sort of errors, alright? So I'm gonna blame the TempleOS font. Okay, so the thing I want to do, I want to actually see at which point this entire thing will probably hang, and maybe that will give me an idea. Okay, so it doesn't hang in these particular situations, which is probably nice, I guess, maybe, I don't know, we'll see, the winner gets tea. So, alright, okay, of course I'm an idiot because Alright, so I removed it. Success. Right, so, and that means I need to take the entire thing in here. Right, success. I'm gonna put it in here. If success, do that. Right, and what I wanted is basically like this. Right. And there we go. So it didn't even print anything, which makes me okay. No? No? Not that? Not that? Also, what if I bring back this thing? Y less than max y. Okay, so it kind of stops now, but does it even print anything useful? In terms of like, does it give us any useful information? Okay, so, and yeah, so that was a bad idea. Well, we already been there. We already been there. So this is not how it is going to work. Though, I think I have to do it slightly differently. And why less or equal max y? No, not really. No. Greater than mean one? Because it's the other way around, isn't it? Yes. I think that's the case. I think that's the case, because x can be bigger than x, and y, yeah, y grows up, y grows up. That means we only want to stop. We only want to stop when oh, this is the OpenGL coordinates that always mess up with my brain. They always mess up with my brain. I hate them. I really hate them. So, one more time. Maybe I need to draw that, because since I'm a programmer, I always think of y going down. And when I have to do the mathematical things when y goes up, it actually messes up with all my wiring build up over the years. So I just can't comprehend that. Right, so because of this, x, y, so this is the, I can't comprehend that, like, really, so I have to rewire everything in my brain. So minimum x is this one, maximum x is this one, right, so minimum x is this one. But minimum y has to be this one, so that means the first point actually points somewhere here. Right, so, oh my god, it's like, it messes up with my brain all the time, I'm really sorry. So, and the maximum x is like this, but the minimum y, the maximum y, is like this. So, if it's lower than the minimum one, so it's like flipped around and it's just like, oh my god. So, yeah, alright. That's why I could not understand that. So y is, while y is bigger, so it's actually bigger, so it stays around like this area. But if at any point it goes smaller than this minimum, that means we should stop. Okay, so that makes a lot of sense. Finally, that makes a lot of sense. And what I'm thinking is that maybe we can do y. So let me see the region in which we want to do y then. Right, because that means y can be positive, all right? And then, to be fair, y can also be negative, but to what extent y can be negative, right? So if I put something like -5, right? So, yeah, look at that, there is like a whole, oh, that's a very interesting like thing in here that creates, yeah. So, and what if I do -10, right? What if I do -10? Do we have any additional information? At some point it just like always succeeds, which is kind of weird, right? Which is kind of weird, but okay, so let's actually do -100. Okay, so that's a lot, so maybe we missed the whole thing. Let me see. All right, so -100 doesn't make much sense. Like, what about -20 then? Okay, so -20 does make sense. Okay, so you probably can go further in x, can you? Probably not. Right, if I do like +1, after +1, okay, so that's the entire thing essentially. And there's like this weird square where you can do this stuff. Right. So I'm just trying to understand what's the possible, like, can I just do min y? Right, what if I put like 10 in here? What if I put 10 and there is like 6 of these things in here? Right, if I put 1, there's, okay, so I feel like I can just use min y. That's what it feels like. It feels like I can use min y. Right. And what about x? Do I have to do... Well, yeah, I can actually go high up, but to what extent? Right, to what extent? Does it make sense for me to... Yeah, I don't know. So Vx is gonna start for that from this thing, min y. Right, because if you're gonna do min y, right, even if 1 bigger than the entire min y, you're gonna just basically skip the whole thing. Right, so you're gonna just tunnel through the entire thing anyway, so it doesn't matter. Right, so bigger than that doesn't make any sense. The upper limit. I have no idea what to do with the upper limit, to be fair. Can I just like don't care about this thing and simply, yeah, I have an idea. What if I just make it very, very big, right? What if we make upper limit huge, right? So, and yeah, maybe somewhere there we'll find something. Right, so at some point it just like takes like a second or two. Right, so this is half of a second, so 2000. And if we take a look at the actual input, I'm pretty sure if we go with y to up to 1000, we're gonna roughly hit it somewhere there, if you know what I'm talking about. Right, so yeah, maybe we're gonna actually do it like that. So we're gonna basically eyeball it, right? So we're gonna eyeball the brute forcing. So yeah, it's fine. And we'll see how it goes. So now I need to implement the actual like solution or whatnot. I64 answer is going to be I64. So we have to find the maximum. So I'm going to put the minimum in here. So let me now do if it is a success, right? If success, if success, answer is going to be maximum I64 between the answer and the max.h, right? And then I should be able to simply print the part 1, right? So part 1 is going to be D, and this is going to be answer, right? So, and we're going to do that on a sample first, and it didn't even, oh yeah, I also have to store the coordinates. I keep forgetting that I need to know the coordinates of this entire stuff. So, okay. So this is not just answer. Let me query replace this entire thing. So it's going to be answer. It's more of a like answer max height. Max height, replacing everything within the selection, right? So boom, boom, A max H, and there we go. So, and then we're gonna have things like I64 answer this, and then I64 answer this. And for this entire thing, maybe we want to put some sort of like values that stand out, maybe I64 min, and this is gonna be I64 min. Temple OS, I hate it. Okay, so if it's successful, right? So we have to do slightly different thing. If it is successful and the max height less than this thing, we have to do this stuff. I really want to delete the whole line until the end, and it doesn't allow me to do that easily. Okay. Okay. So AVX, VX, AVY, VY, and A max H, max H. I'm pretty sure there's like a way to solve it mathematically to just nail down the answer precisely analytically, but I'm a programmer. I don't give a shit about that mathematical bullshit. So let's go. I have a computer on my side, and the computer can just like brute force this shit, so who cares? AVY, AV, and there we go. So it was a 69. Was it 69 actually? It is. So the above example is 69. Cool. So in the above example, using initial velocity 69 is the best you can do, causing the prop to reach maximum Y position 45. I wonder if we can actually, you know, and what is the highest Y position it reaches? Wait, I'm an idiot. Yeah, well, I mean, I needed that information to just to confirm that it is correct. So I think I'm an idiot, so I don't need that. So A max H, and it's going to be basically 45. Alrighty, so let's do the actual input. So here we have min X, which is 175, max Y. Ooh, max Y is min Y rather, right? Min Y. Minus 34, max X is 227, and then min max Y I set, minus 79. I really don't like this way of doing things. Right, so I'm probably gonna do something like this. Right, so min X 170, and then that, and then this, then that. So this is minus 134. Okay, so and let's switch to the input. So it's taking a little bit more time. Okay, 8911. Is it going to be correct? Is it going to be correct? We are about to find out. Probably not, because I'm an idiot. Yeah, it is correct. Okay, cool. I wonder what's going to be the part 2, because like the part 2 this time is not particularly obvious, right? So, yeah, we'll see. Maybe it's even more, maybe something that will invalidate this approach, right? So maybe brute forcing for the part 1 is okay, but for the part 2 is not going to be feasible. So we're about to find out. Let's go ahead and see. Okay, maybe a fancy trick shot isn't the best idea. After all, you only have one prop, so you had better not miss. To get the best idea of what your options are for launching the prop, you need to find every initial velocity that causes the prop to eventually be within the target area after any step. In the above example, there are 112 different initial velocities that meet this criteria. How many distinct initial velocities value? Don't I already have the code for that? Excuse me. So I think I already do have a code for that. So let me... are you serious? Count plus plus. And let's go. Part 2. Count. And let's take a look at the sample. And 40... So 112 different initial velocity values that have this criteria. Okay, so that didn't really work. I see. Okay, so that's cool. That means I need to slightly refactor this entire idea. Okay, so it's more of a like this, right? So this is the condition. And I want to move the count somewhere here, right? So this is the count now. And now I need to just auto-format it. I wish TempleOS had auto-formatter. But Zodin, why don't you implement auto-formatter for TempleOS? Well, why don't you implement it? Okay, so let me see. So that should be it. It didn't compile. 79, and what do you want from me? I don't understand what you want from me. Unused variable saved begin, invalid L value at 79. Where is the 79? A max H, invalid L value, invalid L value. There's no invalid L value anywhere. It's 70, so there was like 75, but it's like not telling me. Shit about that. Okay. Anyway, so it does work for this entire thing, right? So, and let's try to maybe switch to the input sample, and let's see. So, and for the part 2, we have 47, 48. Is it going to be 47, 48? Okay. Cool. I guess the additional challenge here is that you can spend a lot of time. So maybe the trap of this problem is to nerd snipe you, I think. I think this is the main trap of this entire problem, because I can see somebody being nerd sniped so hard they will go deep into differential equations and simulations of physics and stuff like that to come up with a single formula that gives you the answer right away, right? I can see somebody being nerd sniped for like a couple of days doing all of that stuff, but in reality you can just like brute force all of the possible things and it will just work. Right, so it's just like choose your own adventure, essentially. Choose your own adventure. Okay, that's it for today, I suppose. This was the 17th day of Advent of Code in the God's Temple. See you on the next one. And love you.